Hello and welcome to another presentation on the DevOps Handbook. This is CIT 262. We are Group 7, Alexandra, Lozano, Pincay, and Brittany, Herrera. This week we'll be going over Chapter 13, Architect for Low Risk Releases. All right, so let's begin. Jez Humble observed that the architecture of any successful product or organization will evolve over its life cycle. And Randy Shoup, who is the CEO for eBay and Google, observed that both eBay and Google were each on their fifth entire rewrite of their architecture from the top to bottom. The challenge is how to keep migrating from the architecture that we have to the architecture that we need. In the case of eBay, when they needed to re-architecture, they first would do a small pilot project to prove to themselves they would understand the problem well enough to even undertake the effort. I think this is a good example that we all could use on how to implement. The strangler pattern, or the strangler application pattern, it's instead of ripping out and replacing old services with architectures that no longer support the organizational goals, what happens is all the new functionality is implemented in the new services. They put the existing functionality behind the API to avoid making further changes to that. The strangler application is really useful for migrating monolithic applications and tightly coupled services. Over tightly coupled architectures are easy to spot, and they usually cause big global failures. Even small changes to them takes a lot of communication and coordination over many weeks with groups that are affected, and it can cause a lot of fear and can cause a downward spiral, which is basically the second law of architectural thermodynamics. Reducing the effects of the downward spiral, well, we become a loosely coupled architecture with well-defined interfaces that enforce how models connect with each other and promotes productivity and safety. So we allow some freedom, but we keep things local, and then we keep testing locally, which can prevent more errors globally. Okay, with Google, Gmail had several layers of services underneath it. Each layer focused on very specific functions, and each service was supported by a small team who built it and run their functionality, making different technology choices. The same thing with Google Cloud. Service-oriented is architecture that allows small teams to work on smaller and simpler units. Each team can deploy independently, quickly, and safely. This type of structure creates the flexibility and scalability that helps small teams become very productive. Architectural versus monolithic and microservices. Monolithic architectures are not always bad. They're actually good when things are in the early part of the product lifecycle. The functionality, though, of any product or service does evolve over time and should be evolving to keep the needs up to date and met. So the monolithic version 1 versus the monolithic and microservices, here's the pros and cons. The first one is simple at first with lower enterprise latency. It has a single code base and one deployment unit. And the cons are the coordination overhead increases as the team grows, and poor enforcement of modularity, poor scaling, all or nothing basically. And then the next one is the pros are it's simple at first, the join queries are easy, and the single schema deployment is good. Cons are a tendency for increased coupling over time, poor scaling and redundancy, and it's difficult to tune properly. And then microservices, the pros are each unit is simple, independent, scaling and performance, independent testing and deployment. And the cons are many cooperating units, many small repos, and it requires more sophisticated tooling and dependency management. And then we go on. Amazon architecture transformation. All right. One of the most studied architecture transformation occurred at Amazon with Jim Gray. And basically they had a monolithic application. And the lessons they learned was when they applied rigorously, the strict service orientation is excellent to achieve isolation. Lesson 2, prohibiting direct database access by clients makes performing scaling and reliability improvements to your service state possible without involving your clients. And lesson 3, development and operational process greatly benefits from switching to service orientation. The services model has been a key enabler in creating teams that can innovate quickly with a strong customer focus. Use a Strangler application to evolve. So the term Strangler came from Martin Fowler, who was inspired after he saw some strangler vines on a trip to Australia. He said they seed in the upper branches of the fig tree and they gradually come down to the tree until they're root in the soil. Over years, they grow into awesome things. Meanwhile, they strangle and kill the tree. So by creating these Strangler applications, we avoid merely reproducing the existing functionality in some new architecture. But basically, we start at the branches, and then it ends up taking over the roots. I think that was a great explanation of how Mr. Fowler came up with this. The Blackboard Learn case study. Okay, so it was a $650 million company. In 2011, they were still using a code base from 1997. So the CEO, David Ashman, observed that they were having problems. The larger the product got, the larger the lead times got, the worse the outcomes, and the more errors. So they implemented the Strangler pattern. He focused on implementing a re-architecturing code project where they used building blocks and were able to have people work independently. They basically got a lot more code lines in, and were able to avoid problems with their monolithic huge code base that was it was scary to look at, but also had some big risks to cause global problems. And they had much success with this. So the conclusion, all right, to a large extent, the architecture that our services operate within dictates how we test and deploy our code. This was validated in the Puppet Lab's 2015 State of DevOps report, showing that architecture is one of the top predicators of the productivity of engineers that work within it and how changes can be quickly and safely made, because we're often stuck with architectures that were optimized for different set of organizational goals or for an era-long past. We must be able to safely migrate from one architecture to another. The case studies presented in this chapter, as well as the Amazon case study previously presented, describe techniques like the Strangler pattern that can help us migrate between architectures, incrementally enabling us to adapt to the needs of the organization. This chapter was really, really good. It really gives insight how to change a huge monster one thing at a time and be successful with it. We really enjoyed going over the chapter. Hope that you enjoyed our presentation. Please let us know if you have any questions. Thank you so much. Bye.